Hey, thanks everybody for spending a few minutes with me as we go through restoring damaged files quickly. So I'm going to spend a brief few moments just introducing myself. My name is Tony Klinger. I'm a cloud architect with Panzura. Prior to that, I spent about almost 20 years doing data protection, disaster recovery, and business continuity. So restoring data is something that I've done, throughout my career, and is definitely something that's passionate to me. And I, share some of the pain and experiences that I've gone through in the past, and then show you exactly how Panzura can help you guys solve challenges around large data restoration. Before we dive directly into what that recovery process or Panzura recovery systems looks like, let me just give you a little bit of background of where we're going to go today. We're going to talk about data protection legacy process around data protection. I'm going to introduce Panzura obviously to you guys, show you the difference of how Panzura does it, the immutability features that we have in our product, and how we can essentially eliminate the need for backup and restore. And what that means is we're going to give you the ability to do large file recovery, large file set recovery very quickly, without having to do the traditional backup methodology. So with that, if you have any questions, drop them into the question panel. We'll address those at the end. But let's dive right in. So who is Panzura? If you've heard of us in the past, you've probably got a reference to, they're a filer, they're an edge file appliance, they're a gateway. Those are not all inaccurate assumptions or awareness of our product, but just to kind of bring you full circle, we have really grown since 2008 in who we are and what we do. We've got 35 patents, 17 more patents that are pending. Been around since 2008. Traditionally, we're a hardware-focused product. The new model and the new solution offering that we're bringing to the market is more around software as a service. So we're providing software that'll run in your environments, capture your data, protect your data, write it into object store on the back end. And I'm going to go into detail of what that looks like. But the value here is we are the original cloud, hybrid cloud providers. We view ourselves as, an innovator in the technology or in the space of hybrid cloud data storage. An 87 on the NPS score shows you that we're not just running around throwing technology out there and not making sure that it works or not taking care of our customers. So very high net promoter score. Our customers are overly satisfied with our product. We simplify how they manage their data. And that's in a couple of different ways. But we're able to provide a CloudFS file system that reduces the need for data replication, data storage across multiple layers. We're going to provide an edge appliance that runs in your data center or in the cloud that will receive your data, securely protect it, put it up into the cloud, into an object store. So we're dramatically reducing your cost. But we also have features and analytics and services around helping you monetize that data. So once you store the data, it doesn't just sit there and blow hot air and consume money and continue to grow exponentially. We see customers on a regular basis have exponential data growth from day to day and week to week and year to year. That has tremendous cost associated with it. But the most important thing is your data is your asset, your value to your company. If it's lost or if it's contaminated or ransomware affected, it's probably going to mean that you're going to go out of business. You're going to run out of the ability to be able to recover. These are just some stats that exist in the market. This applies to data protection across the board, but greater than 90% of the companies who have some sort of data outage or major data loss end up going out of business. So that's where the history of my background comes from, being a data protection subject matter expert. This is the traditional mindset. Do backups or do data replication. You have a primary storage appliance in your primary data center. You're going to do some sort of HA replication of that. You're putting it at a secondary location. Then you're doing backups of it. You're storing those backups, and then we're taking those backups and we're putting them off-site. We're putting them somewhere at a DR site so that they can be recovered. Every movement of that data introduces complexity and risk into the environment. but it also introduces a lot of cost. So the same version of one file as it's stored in the primary storage array is now got 3 more additional copies of it being put out there that you're managing. So this isn't just about disk storage costs, this is data center costs, this is engineering cost, admin cost, support cost, security cost. All of these levels of data management introduce a lot of extra cost into your environment. And that's where Panzura is really doing this differently, and how we're solving this is we're eliminating the need for all of these redundant copies of it. Let's just assume you're doing a data domain or some sort of high deduplication and compression of that data and still making copies of it. You've now introduced a backup software to write to that backup appliance that's deduping and compressing, and then you're making multiple copies of it. So there's a lot of different areas of cost and risk associated with the backup technology as it exists today. If you have any backup software or talk with any of your backup vendors, you're going to hear one of these methodologies or strategies deployed. Or if you're talking to your backup and storage admins around data protection, disaster recovery, business continuity, you're going to see some picture like this. And if you're using a Commvault, TSM, Net Backup, any of the legacy and or new Rubrik Cohesity backup products that exist out there, you're going to be having this conversation around how many copies of the data and where do we store it and how do we make sure it's available and how do we have redundancy in it, and what happens if we have ransomware attack at the primary storage and gets replicated to the high availability, the secondary storage array, and then it's backed up and it sits in our backup infrastructure. How do we make sure that we can actually recover that data? These are all complicated conversations that involve a lot of pain in our existing technologies today, or in a lot of the IT infrastructures that I'm working with today. But at the end of the day, backups are only as good as restoration. So if we're backing all this data up and we don't have a tested practice of recovering it, we don't have a good procedure around where do we put that data when we do recovery. A lot of backup strategies or disaster recovery, business continuity strategies are trying to move into a cloud solution. What does that cloud solution look like? How do we manage that data and recover that data in a cloud environment? Does it make sense to buy new hardware to build out a secondary location, right? So I kind of set the foundation of the complex environment that backups are, and restoration is what makes you successful. Your backups are only as good as your ability to restore them. And what happens if you're backing up bad, corrupted data? Now, how do you know when and where and what is a clean copy that you're able to do restore without going through multiple iterations of data restoration? And the history of backups require, especially on the unstructured data, the NFS SMB space, requires massive data movement. So if you're in healthcare and you've got PACS information, if you're in security or you're doing something with cameras and you're backing all of that stuff up, you're consuming large amounts of data storage, and you're doing it multiple times and having multiple copies, and you're praying that you have the ability to do recovery. What about trying to do a single file recovery if you needed to do that restoration? How many layers of IT support have to be involved? Is that a help desk ticket who then has to have somebody go run a query to try to find the file? What does that process look like? How long does that take? So, the traditional way is very archaic, it's very painful, it's very challenging. And it leads to the question of, okay, so you've told us how bad everything is, now tell us how we can do it better. And that's my vision here, is to kind of give you guys some background as to who Panzura is and how we solve this problem for our customers. So this is the complete end-to-end view of Panzura from a standard offering package of what we bring to the market. If you look at this infrastructure from the bottom up, your bottom layer is your data layer. This is the cloud infrastructure. This is where we're going to work with you to identify unstructured data, NAS, NFS, SMB data that is a candidate for storage in the cloud. And what that means is we're going to put a filer at your location. We're going to have the ability to capture the data just like you would today with NFS and SMB. NAS data, we're going to capture it, we're going to dedupe, compress, and encrypt it, We're going to communicate it across multiple locations and write it into the cloud object storage, into your object store in a manner that is 100% immutable. And I'll show you what that means, but that's your protection from ransomware. We also give you the ability to run analytics, and that's the yellow layer above that. We're managing and monitoring and separating that metadata from the actual data, and we're doing intelligence, AI, with that metadata to be able to help you identify when you've been hit with ransomware. So we're going to be able to identify that you've had a user touch 500 files in an hour and give you the alerting and the reporting that says this user may have been compromised. These are the files that they touched. And now your team, your IT security team, has the ability to go in and look at those files. They can do a restoration of them. They can run antivirus against them. They can try to open them and see exactly what's going on in there. And I'll touch on that a little bit deeper in just a minute. But at a nutshell, we're providing the complete view around unstructured data management. We're managing the data at the edge, providing it to you and your users in a way that you're familiar with. It increases performance because, as I mentioned earlier, 90% of the data that you store in an unstructured format is not accessed unless, in more than 60 days. 60 days has been what we find. Most of your data is being accessed in those 60 days. 90% is legacy data that's just sitting out there, requiring backups, requiring space, cooling management associated with it. So what exactly does the topology look like a little bit deeper from a technology standpoint? So Panzura is going to run as a software package, a virtual machine in your locations or in the cloud. So you'll see site 1 and 2 are physical locations. Site 3 is a cloud deployment. We're in most of the marketplaces of the major cloud providers today. You're able to run us as a virtual machine. The NFS and SMB file shares that you're used to seeing at your edge, at your end user locations, those projects 1, 2, and 3, all of your data is there. So it's a global file system. We manage the locks at the filer. So those hashtags, those virtual machines running at each of those locations are in constant communication with each other. It's a SSH communication between each of those sites. When we receive a file, and I'm just going to use New York for an example, when we receive a file from a user in New York at the file system, we're going to separate the data from the metadata. If you look in the cloud, you see a red blob and a blue square there. The metadata and the actual data are separated. The metadata is shared with all of the other filers immediately once it's received at the filer in New York, once it's created. And then the actual data will be deduped, compressed, and encrypted, written into the cloud object storage, and then made available to all of the other filers. So within 60 seconds, every filer is aware of the file that has been created, and the data is secured into the single source of truth object store, that authoritative data source in the cloud. So this eliminates the need for the HA replication, because now we have the file data available at every edge, at every location where the filers are presenting the data, and your users have access to it. If a user tries to access the same file that somebody else has open, so a user in New York creates a file, has it open for edit, a user in London decides that they would like to open that file, they're going to get an alert that the file is locked. They can create a new version of that. They can get a read-only copy, or they can wait for notification that that file's been done, released. The lock has been released. And at that point, that user can, they can see what's going on. They're able to manage and look at that file, but we're protecting it at the filer. So that, that's the basis and the foundation of how we manage the data and how we eliminate the need for redundant copies of the data between multiple sites by storing it in the cloud. And there's probably a thought that somebody's having out there of what happens if that cloud becomes available and what clouds are supported. Really, it's anything that presents as an object store. The S3 technology that exists, if you present as an object store, we're able to write to it. There's a listed compatibility matrix on our support page, but most of them are available. And what happens if one of them is offline or becomes unavailable? So let's just say you choose Wasabi as your primary landing zone for that backup or for your cloud object storage, and Wasabi is not available to service your request. we have cloud mirroring, so you're able to write to two clouds simultaneously. Additionally, you can use AWS, Azure, Google. They allow for regional copies of that object store, so you could have AWS object store in East and AWS object store in the West. You have the ability to separate the access of the data across AWS, but if for some reason you're not able to access one of those primary receivers, you can use the Panzura cloud mirroring feature. So a little bit, back up just a minute here on this slide and a little bit about the encryption and the data immutability path here. So I mentioned when a file is received or created and it's received at the filer, we separate the file data and the metadata. As I said, the metadata is shared, stored at the filers, and available to everybody instantly. But what does it look like for that file data when we receive it at the filer? We break it into 128K blocks. We deduplicate, compress, and encrypt it. And then we store those blocks in objects that go into the object store. And this is where our immutability comes from. When a user or a ransomware attack occurs, when a user makes changes to it, they don't change the original blocks of data. They actually create new objects. So the bottom half of that second column here, we're actually going to create new objects and we're going to store those in the cloud. So we do not have a need to actually do backups because we're maintaining the original versions of those blocks. And so if somebody comes in and thinks that they're locking this file from a ransomware standpoint, we can very easily revert back by just going to the previous blocks prior to that ransomware attack. So we store all that in the single source of truth. Again, a common question that we hear is what happens to the Panzura filer configuration if this is running as a virtual machine, somebody comes into VMware or Hyper-V or Acropolis, we support all of those, but comes into one of those and actually manipulates my virtual machine, takes it down, corrupts it. We store the Panzura filer configuration in the cloud, so we're able to restore that filer. Additionally, we have the capabilities of running an HA system. So that Panzura virtual machine, we can run a second Panzura virtual machine as a high availability. And so if those are on different VMware hardware or different data centers for that matter, if one of them goes down, the primary goes down, the HA box can masquerade itself or present itself as the primary and take over the responsibility of that box. That eliminates a lot of the need. We've also kind of found that attacks on the vCenter or the VM hardware or VMware farm don't really produce a lot of value to a hacker because most people don't pay ransoms to recover that. It's just a nuisance. So it's not a high attack location where we see most of the attacks are infiltrating the infrastructure, the file system, and going in and actually doing ransomware locks of the files. And that's where our immutability comes into play with that. So what does it look like? How can we say with confidence that we can eliminate backups and then provide faster recovery? Because we're mapping those changes of the file data down to 128K block, and we're storing the most recently accessed files or the blocks in that Panzura filer. When somebody wants to do a restore or revert to a previous version of a file, or we need to revert back, we're not actually traversing all of that data out of the cloud back to the filer. We're only providing the blocks that are not already present in that filer. And so in most scenarios, somebody's looking for a version of the file that's been recently accessed. They don't really need to transmit or send every block of data from the cloud down to the filer because we're only going to need to go back and get the old copies that that existed prior to the last change. And we're only getting the 128K blocks or the blocks out of the cloud that are required to rebuild that file with 128K blocks there. We call that a cache miss. So it's data that's not actively present on the filer that we would traverse back from the cloud down to the filer and then present the file back to the user. Remember, all of this transmission between the cloud and the filer is deduplicated, compressed, and encrypted, so it's protected. We're not worried about somebody snooping the line there. This really gives us a lot of confidence to be able to say that you don't have to back all this data up. You don't have to make all those redundant copies of it. You're storing it once as a single source of truth in the object store. Again, if you're concerned about a single point of failure being AWS, Azure, Google, and you can use on-prem storage. We've got customers using MinIO. We have customers using IBM Cloud Object Storage, Legacy Clever Safe that are running on-prem. So these do not have to always be the big cloud providers. There are other object storage solutions that exist. And that gives you that redundancy. So if you're running an AWS primary and a secondary is a MinIO or an IBM Cloud Object Storage, you've got that secondary that's directly on-prem that's available to you as well. So, confidently, we have multiple customers who have been hit with ransomware, unfortunately to say, but we can definitively say since 2008, we've never had a customer pay a ransom to retrieve their data or access the previous versions of their data that are being stored and protected with Panzura. It's a pretty bold statement to say. I'm pretty confident that nobody else in the industry can make that statement with confidence, but we can. We've got use cases and customer experiences that can attest to that, the success that they've had in restoring or reverting back with Panzura, using Panzura to store their data. So moving past how we store the data and what we do with it and what we do relative to Panzura Data Services, storing this data and separating the metadata is a very key value feature to our product. Our ability to do Panzura Data Services analytics with the metadata separate us even further in the marketplace from what you would think of from a traditional NAS footprint. So we offer a software as a service data management layer that gives you the ability to do instant search of your entire global file system within seconds. And I'm going to show you what that looks like, but you can search and say, show me every MP4 or find me a file that that contains New York Project 101, right, in the file name, and you can search New York Project 101 and it'll produce every file in your file system that has New York Project 101 in that file name. And you can search based off dates and times. You've got global search of the entire environment. Not only do you have global search within seconds, but you have audit capability. So you can look at that file, audit the file, and identify movement, access, changes, deletions of that file. So let's think of GDPR, for example. Maybe you're concerned about data leak out of one location to another, out of Europe or out of EMEA into the US or into an unregulated environment. You're able to identify who did it, when they did it, and then what happened to that file while it was in the other file system. So if you've got a UK file system and a US file system, and somebody, I'll pick on myself, Tony decides to grab that file and copy it over, you can self-report, reduce or eliminate the need for GDPR fines and say, hey, here's that file. It was accidentally moved while it was in a US file system. It was not accessed by anybody. It didn't have any changes, and you're able to self-report and protect yourself in that. Think about from a military standpoint, if you've got classified or unclassified information, intellectual capital, if you want to identify that somebody is copying multiple or hundreds of files out of your infrastructure, multiple files out of your infrastructure, maybe they're copying it to a local drive because they're preparing to exit and they're taking intellectual capital with you. We have the ability to monitor and alert to say, Tony's copied 500 files in the last hour. Something is going on here. Somebody needs to check into Tony, or you can shut down his ID from an AD standpoint and go and analyze and see exactly what Tony has done or what I've done in that scenario. And this is how simple it is. So this is Panzura Data Services at a high level. You click on it, you say, hey, let me find all the PowerPoints. Click on that. You're able to, on the left side, you can put date ranges. You can tell it exactly which filers you want it to look into. And then you can sort on all of these different columns over here. You can export a list that says, okay, here are all the PowerPoints. This is our demo lab. In this example, I just searched for PowerPoint. There's 410 results. I didn't put any date ranges or anything on it. But let's say we want to identify what happened to the Bob.original PowerPoint. Show me the history of that. So we're able to search on that. We can see the history of it. just by, running a simple audit search here. And this audit allows us to minimize exactly what activities we want to see. There's actually a line down here at the bottom you can see based off the user. So I want to see everything that in this case, it's Bob Hart, but Rob Hart did on this example. Let me go see everything that he did to this environment, and that's in this user column here. So this is very powerful intellect and knowledge that you have on top of Panzura Panzura Filer CloudFS. This is the Panzura Data Services feature. But specifically, if we wanted to do a single file restore, and I've got a highlighted here of Bob's original PowerPoint, you can go up to the top right. If you click the check mark, you go up to the top right and hit recovery. You're going to get a window that says, hey, where do you want to put it? This is how easy a restore is within your entire file system. So if you want to search for the file, identify it, see what happened to it, put it back into its original location or into a different location, it's that simple. It's right here. So this is, around the analytics, and this sets the foundation of what we're going to do next. It shows you and what it makes sense with. But this is, Panzura Data Services, how we're able to assist in identifying what's going on in your environment, complete search and audit capabilities, including single file restore or multiple file restores, but you can restore, one or two files through this path. But let's go take a look at what happens and what the environment looks like when you need to do a massive file restoration. So I'm going to run through a little video here and talk over it. But in this scenario, we're going to show how to restore an entire mount point or file system or directory inside of a Panzura CloudFS deployment. So we're going to go this. So this is the Panzura Filer CloudFS interface. This is what your admins would have access to when they log in to their environment. From a CloudFS standpoint or the Filer standpoint, they're going to see this information. So we're going to go into the maintenance mode. We're going to go to CloudFS operations, which is here. And then we're going to browse the CloudFS infrastructure. So this is what our CloudFS environment looks like. You're going to see there's two subordinates there, and there's one master. So the -S's are our subordinates, the master is our main system. At the top is snapshots. That's all of our snapshots in this environment. So, apologize for that. So all the snapshots that are in the environment, when you look at that, when you open up the snapshot directory, you're going to see nightly. I apologize, I hit reset on that. You're going to see the nightly snapshots and the hourly snapshots. Those snapshots are running on a scheduled basis. Here they are. So these are the hourlies. In this example, we're going to pick on the nightly one here. So nightly 3. When it opens up, you're going to see the subordinates and the master again. We're going to click on the master. We haven't started a restore. We're traversing the file system right now to identify what we want to restore. So we're going to click on the master. We're going to see that there's an NFS directory in here from November of 2021. We're going to click on manage because we're going to want to restore that. So we're going to go restore a version of that. So we're going to hit restore here. Again, we're restoring from CloudFS snapshots, the NFS directory that existed there. So now we're going to talk about where do we want to put it. We're going to put it back on the master. You have the options. You can put it into the subordinates or the master. Notice that there's no NFS directory there, and that would be the same of these subordinates and the master. So we'll go back to the master. The NFS directory is not here, so we're going to create it. So we'll copy the path of where we want to put it. We're going to create a new folder. Again, NFS isn't there, so we're going to paste in where we want to write this restore to. We're going to put NFS in there, create that new directory. We're restoring from the snapshots on the original CloudFS of the master server, and this is nightly 3, so we were able to see that version. We're writing it to the new location on the master, which we just defined as the NFS. There's a system resource utilization here. This would be about setting up how many resources we want the master filer to use when it does the restore. So we just hit start. That actually initiates the restore. You would see the restore show up in this restore task window. We're going to need to refresh this screen to get it to come up. So we're going to X out of this screen here. We're going to go back into manage. so that we can see the restore process. So we'll go to restore versions. And now you see in that restore task section, you see that this job is running, and you'll see the path of where it's coming from and where it's writing to. You notice the destination there. You'll see that this is running and it's in progress. It shows a progress report. It's showing you transmission speed, number of files that we're actually doing. It has a cancellation option there. If you wanted to cancel this restore for whatever purpose, you decided that you didn't need to do it or you did it in error, you're able to see exactly number of files that are being restored and what's left or has been restored there. So what was that? What does that really look like on the back end? So that's the admin side of this, this restore process. What does this really look like from a user interface standpoint and from the admin standpoint when we're running those commands? So on the top left, you see this is the file system that the end user would see. It sees big data and data. There's no NFS directory in there. Somebody says, oh no, I need that NFS directory back. Let me see what file was in there that I need from the previous version. They call support. Your support team that has access to the CloudFS goes in and does a massive restore of the NFS directory, writes it directly back into the location of where it was, doesn't actually move all of the data into the directory. It's putting all of the metadata in there, and it's giving the user the illusion that all of that data is available to it. So when the user goes in and clicks on this NFS, they're going to see the metadata and the infrastructure as if it was there. They're going to click on a file that they would like to open, and they may wait 1 second to 2 seconds while that actual block of data that's required to recompile that file comes out of the object store to the Panzura filer and then is presented to the end user. This is very, very low wait time. The response is, incredibly fast because Panzura is anticipating as they're moving around and they're clicking on the files that it's anticipating what data the user is going to request or going to need, and it's preparing for that transmission of the data. The data is received at the filer and then presented to the end user. We're not going to transmit every block of data or every file unless it's necessary, and that's when we put it into the cache. The other beauty to this, if any of those 128K blocks are already in the cache, we talked about that cache hit versus cache miss a little while ago. If it's already in the cache, then we don't need to traverse it out of the cloud. We're just going to provide those blocks because they're already in the filer, right? But let's look here at the bottom left for just a second. If you notice the, 238 objects or files that were, restored or made available to the end user, it took about 80 seconds. If you look at the math on the 1628 start time versus 1632, there's a little bit of lag in the seconds there. But it happened incredibly fast, right? We were really fast to restore that file. We didn't actually have to traverse or transmit every block of data. We were able to provide that data to the end user within seconds of the start of that restore or retrieve process. Again, that NFS file system will now be present on all of the filers that had access to this CloudFS environment or this ring. So we've now made that data available to all users. You can restore to different directories. You can isolate users based off a directory that you restore into. So if you did have some data that was corrupted and you're restoring, and maybe that NFS you had a ransomware attack identified in there, and you don't want it to be available to the end users, and you want it to go into a directory or a location where only your security team or your antivirus team has the ability to go in there and identify what ransomware attack hit you, you can then run that, isolate the infection, resolve it, kind of in a quarantined state, and then once you've identified what patch of antivirus you need to run across the entire file system, you're then able to go back and run that across the entire file system and have protection of the entire file system against that ransomware attack. So hopefully that kind of makes sense and lays out the environment of how we do massive restoration, how this is so easy and fast because of the way we're protecting the data on the front end and receiving that data. But if any of what I said, I kind of went quick, if I said it and it didn't quite make sense, as you become a Panzura customer and you start deploying our VMs and our CloudFS into your environment, you have premier support with all of our agreements and all of our contracts. That's a 24/7, 365 support agreement. You're going to have quarterly business reviews. Our team is going to be monitoring and managing your environment or having some oversight in your environment. So if there's concerns, if we see that you're growing quickly, or if you're having challenges with ransomware and you get attacked, pick up the phone. Our support team is here 24/7 to support you guys. I mentioned earlier we have an 87 on the NPS score. We're pretty proud of that. We work really hard to take care of our customers. We will recommend upgrades. We'll work with you to do the scheduled upgrades. We actually do migration assistance. So as you migrate off of the legacy products or traditional NAS infrastructure and you go into an environment where we're distributing this and sharing this across multiple environments for you or multiple locations for you, you have our team supporting you to make sure that this goes successful. So with that wraps up what I've got from a webinar standpoint. I don't know if there were any questions, Petra, or if anything came in.
Thanks, Tony. Yeah, a couple of questions. First one, how are snapshots themselves protected from deletion or encryption?
Right, so we're actually writing those snapshots directly into the cloud. So they're using the same immutable feature set that we have within our object store. So when we create those snapshots, as you saw that .snapshot directory, we're writing them into the CloudFS and then also putting those directly into the cloud. So we have the ability to restore them from multiple filers, but they're obviously coming out of the cloud, so they're protected from that immutable standpoint as well.
Perfect, thank you. And last question, which version of CloudFS is the mass file restoration available in?
We are currently on 8.1, and the mass file restoration is a feature in 8.1. So is the cloud mirroring as well. So
perfect. And that looks like it for questions, although I have a comment. Very grateful for Tony and his team who are assisting me at the moment for a master controller migration. There you go.
So.
Oh, and it looks like we've got another one for slides. David, we are recording this webinar. I'll send you out the link possibly a little later on today. If not, it'll be tomorrow. Sometimes it takes a little while to get the recording rendered. So you will be able to see this at your leisure. And that looks like it. If there are any other questions that you think of after we finish this, just email them either to Tony or to myself, and we'll take care of them for you. Thank you very much, everybody, and enjoy the rest of your day.